All right, welcome. This is the ELM Test Prep Series by James S. I'm James. Let's look at system of equations. Well, the term system of equations seems to almost invoke in our mind something evil, and sometimes you're probably right. But let's look at generally the idea of what we might call a system of equations. And essentially what we're looking at is two equations. Well, a system means two or more equations, and we have two equations here. This is some y equals, we'll say 1/2 x minus 1, and we might say this is y equals minus x plus 5 or 10 or whatever. It doesn't really matter. All the points on this line are defined by this equation. If you pick some x to go by, then you will get a y out of that. So if I picked an x over here, I would get the y that put me on that point. And all the points on this line are defined by this equation. So some x here would give me a y. If I had an x here, it would give me that y. Well, over here, it would give me a y down here. So I have 2 points with the same x. As I get approaching this x value, my y's begin to come to the same point. So my solution here is where I have the same x and the same y. X here gives me a certain y, and x gives me the same y out of this equation. So we call that the solution to our system. And as such, if the x and y equal each other, then this equation equals this equation. Y equals y, x equals x, and therefore this equation equals that equation. And that will be the way in which we will resolve or solve our equation, our system. Well, we have some problems that are involved in systems of equations, and I'm not sure whether they'll give you one of these, but essentially parallel lines never cross. Well, if they never cross, they never have a common value of x and a common value of y, so there is no solution to a system of equations where the two lines are parallel. Well, when I say they're parallel, the slope of this line is equal to the slope of this line. Well, they have the same slope. It's going up the same kind of hill. All right, so how would that look algebraically? Well, x and y, 5 and 7. Now, if these two had been the same value, they would have been the same line. But they're not the same line, but they are parallel, because the relationship of x to y is the same, 1 to 1, 1 to 1. All right, so that would be one way you might see a parallel line. Well, these are actually parallel. The relationship here is 1 to 1. This is 2 to 2, but reduces down to 1 to 1. So the slope of this line is actually the same as that one. And so this is merely doubling those values. I did not double that value, so they are two lines, but they do have the same slope. The relationship of x to y is the same ratio. All right. Well, what if I had this? Are they parallel? Well, here's the cautionary. They're not the same sign. So one of these has a relation of 1 to 1, and the other is a minus 1 to 1. And so they are actually going in opposite directions. They are not parallel, Their slopes are one's positive and one's negative, and so they do have a solution. All right, let's try an example here. In this particular problem, they want to know what x equals. All right, yeah, x. What y equals. Well, they're not in the same form, so we can't just look at them and say, oh my goodness, they're parallel or they're not parallel. But let's assume that they're not being tricky with this, and let's give it a try. What they do tell us is that x, they put x in terms of y. Now remember when I said if we have a solution, the x and y are the same in both equations? Well, because of that, if these are in fact have a solution, the x in this equation would be the same x in that equation. And so that will allow us to dump that value in there. So we're going to substitute the value for x in this one over here and find out where in fact what y value is true. So if the x's are the same, I should get some y where they would be the same. So I'm going to substitute in for x, this x right here. So 3 times 3 minus 2y, there's my x value, and I substituted it right in there. I just went and then I have my plus 5y equals 4. Now I did not change this part of the equation. All I did was substitute in for the x, and so even though it looks different, I have not really tampered too badly with this. So I'm going to distribute this. 9 minus 6y, minus times the plus is a minus, plus 5y equals 4. All right. Well, I have two y terms here that I'm going to combine. Minus 6y plus 5y leaves me a minus 1y. And I have a 9 here left over equals 4. All right. Well, I just have one more thing that I want to do. I want to find the solution for y. So I'm going to subtract 9 from both sides. Minus 9, minus 9. So it goes to 0 on this side, so I have minus y equals the different sign. So I take the difference between 9 and 4, and that's 5, and the largest sign is negative. So minus y equals a minus 5 at this point. But I don't like negatives out here because I want to know what plus y is. So I'm going to multiply both sides by negative. Y equals 5. That'll change that sign, and that is my solution. All right. So I know what y equals. If I needed to know what x equals, I would then take this y value that I found, stick it into that equation, and find my x. But at this point, I'm done because all they wanted to know was y. They were real nice to you. They kind of led you in that direction. All right, so let's find one where they're not leading us quite so nicely. And 4x minus 3y equals 17, and 2x plus 5y equals a minus 11. All right, so, well, the relationship, they're plus and minus, so they're going opposite directions. So I have a slope one way and a slope the other, so I do have a solution. Once again, they're looking for the value of y here. Well, I've got two variables in both of them, and to substitute, I'd have to juggle this around a lot. But what I want to do is, I see that 4x is twice the 2x. So what I'm going to do is I'm going to double this and make it, I'm going to multiply by a minus 2. So I'm going to multiply both sides by a minus 2. Essentially, I'm going to take the whole equation and multiply by minus 2. Well, that'll give me a minus 4x minus times a plus is a minus. 2 times 5y will be minus 10y. And a minus times a minus will be a plus. 2 times 11 is 22. Okay. And then I'm just going to bring down my first equation. All I'm going to do is bring it down here so I can see it a little closer. 4x minus 3y equals 17. Well, I modified this one. So now when I look at adding these two equations together, x's and y's and numbers, I see that this is opposite and equal in value, and they go away and become a 0. Adding minus 10y and minus 3y for a total minus 13y, and 22 and 17 is 39. And then I'm going to simply divide both sides by minus 13. And I will get a minus 3. So y equals minus 3, and that would be my solution. All right. I see we've eaten the clock up on that little process, and hopefully I haven't done anything crazy this time. Hope this was helpful. Have a good day.